Welcome to Study Loop.
So for part A, we can say that the linear speed v at t equals 15.0 seconds would be equal to the tangential acceleration multiplied by t. This would be equal to 0.500 meters per second squared multiplied by 15.0 seconds, giving us 7.50 meters per second. We can then say the radial acceleration would be equal to v squared over r. This would be 7.50 meters per second quantity squared multiplied by 30.0 meters, the radius. This is giving us 1.875 meters per second squared. And so the net acceleration, the magnitude of the net acceleration would be equal to the tangential acceleration squared, the square root of the tangential acceleration squared plus the radial acceleration squared. So this would be equal to the square root of 0.500 meters per second squared quantity squared plus 1.875 meters per second squared quantity squared. We're taking the square root of the sum of the squares, and we find that the net magnitude of the acceleration is equal to 1.94 meters per second squared. So this would be the net magnitude of the acceleration, or rather, the magnitude of the net acceleration. And we can say for part B, we are going to note that the tangential acceleration is parallel to the velocity vector. So we can say that the angle between the velocity vector, rather, we can say theta between the net acceleration and the velocity vector would be equal to arctan of the radial acceleration divided by the tangential acceleration. So this would be arctan of 1.875 divided by 0.500. And we find that this is equaling approximately 75.1 degrees. That is the end of the solution. Thank you for watching.